and share my desktop. How are you guys doing today? All right. Thank you, Robert. Let me see. Let me bring up the agenda. This is the plan for this week. We want to finish chapter 2. So I'm going to do a very quick review. I do want to talk about confidentiality. This is a security class. Much of what I will be saying today is a review, but it's good to review and make sure we have the foundations in place before we start adding to them. And then we'll continue with chapter 2 and chapter 2 labs. Any questions before we start about anything we've done up until this point? Go ahead, Camping.
No, just say answer your questions.
Oh, okay. Okay, the answer is no. Okay, very good. Very good. Thank you. So the week 1 lab is due tomorrow, tomorrow being Wednesday. And I noticed at least a handful or more of you have already completed that. That's great. And I will be grading it no later than Friday. I did say no later than 3 days after it's due. So I should have time Friday to grade. So let's go ahead and get started. Good morning, everybody, and welcome to week 2, CS 285. So last week we talked about hashing, and I said hashing is really important, especially from a security point of view. And we said we have all these different hashing algorithm, and you take a string. The string can be a single character or it can be a textbook, and you put it through this hashing algorithm and it produces a hash key. And we talked about the importance of the length of that hash key. And we said the longer the hash key is, the more secure it is, because the likelihood of duplicates goes way, way down. And this is what cryptographers look for to crack something. They're always looking to see if they can have a second string that can produce the same hash key, or a second input that produces the same result, and that gives them something to work on. And I did say hashing is used a lot. And if you want one word that you need to remember with hashing is integrity. We use hashing for integrity purposes. And if we are to go back to this table, and down here we have a frame, and the frame has a payload, a header, and a footer. And what we have in the footer is a hash key that the generating computer produces, and then each device along the way checks for integrity. And if the integrity is good, meaning that the payload didn't change intentionally or unintentionally, then we send it along. And if the frame has lost integrity, meaning the payload has changed, then we discard it and go on. So this is one way of using this hashing. We also said we use it with passwords. We don't really want to store passwords like we did in the good old days, because system administrators can see them, and that is a security concern. So we hash it, and then when you are prompted for an account and a password, we hash the password and we compare the two hash codes. And then we looked at file signature, and we said file signature goes one step further, and I do want to talk about that today. So we said that we do hash the entire file, we produce a hash key, and then we want to make sure someone doesn't change the file and the hash key, because there's nothing preventing a black hat cracker from changing the file, the string, and then changing the hash key. And it would appear as if the file has integrity when in fact it has been modified. So what we do in this case is after we produce the hash key, we sign it with the private key. So if it's a Microsoft file, Microsoft signs it with their private key. If it's a Google file, Google signs it with a private key. And that way only they can change it. And people that have the public key can do that. So this is hashing. And I hope you've been studying about it, and I hope you're quite comfortable with it. The next thing I want to talk about is confidentiality. And whenever you hear the term confidentiality, you can replace it with encryption. This is how we ensure confidentiality, through encryption. And I'm sure you remember the acronym CIA, confidentiality, which is encryption, integrity, which is hashing, and A is availability. And we said we want to balance confidentiality and integrity with availability. And it depends on the data. That balance depends on the data you're trying to protect. So let's talk about confidentiality, encryption. Whenever we talk about encryption, we're either talking about a symmetric key or we're talking about an asymmetric key. An asymmetric key uses this PKI, public key infrastructure, digital certificates. So let's start with symmetric key. And if you have questions, please ask, and we will have time to finish chapter 2 this week. But these are really, really important concepts that I need you to get your brains around so we don't have to keep coming back to them. And you will see these over and over and over again on a daily basis. So let's talk about symmetric key. Symmetric key is where we are using the same key to encrypt and decrypt. So, and you use it all the time. You password protect a file, and next time you want to use the file, it's going to ask you for the password, and you type in the password and everything is fine. So I created this test file. It's not protected by a password right now, and I'm going to use a symmetric key. Okay, protect document and encrypt with password. And I'm going to go ahead and use a password CS285, which is a terrible password because it's very short. And last week we saw how long it takes to crack a short password. But for what we're doing, it's good enough. Okay, and it's going to ask for it again. Okay, so let me type it correctly this time. Very good. And now if I was to save the file and get out and come back in, it's going to prompt me for the password. This is symmetric encryption. We're using the same password to encrypt and decrypt. And symmetric encryption works super well and works with relatively short keys. And I want to show you that, but let me go ahead and type in the password. Now, if I enter the wrong password, it's going to say, nope, this is the wrong password. And once I type in the correct password, it will open the file for me. So let's take a look at the length of those keys, and the length of the hash code and the keys are super important. So if I was to go to my friend Google and say, you know, how secure is Microsoft Word protection? And let me see, and go to here. Okay. Let me see. Yeah. Very good. So let's take a look at this, everybody. So let's go all the way back to 95, and they were using 16-bit key. 16-bit key is 2 to the power 16, 65,535. So how long do you think it will take a computer to crack a password that is using a 16-bit key? Okay, brute force. Not very long, you know, super short. No matter, you know, what password you're using, the key is just way too short. And that's just 65,000 tries. And that doesn't take a computer, even a low-end computer, very long to do. And then if we were to go to 97, then they made the key 40 bits, 2 to the power 40. It's a lot more than 65,000, but still, this is a very short key. And then if we were to jump to 2007, okay, they use a 128-bit key, which is pretty good. That's decent. Okay, but in 2020, not too decent, but a decent key. And then if we are to look at Office 2016, they're using a 256-bit key. 2 to the power 256, it's a very, very, very large number. And brute force, it's going to take an awfully long time to crack that password. So this is symmetric key. And the keys don't have to be super long. You know, 256, 128, it's pretty decent. But of course, 256 is far better than 128. And Microsoft wants to make sure that they are securing those files using symmetric key. Any questions on symmetric key? And AES stands for algorithms. We have a ton of hashing algorithms. We have a ton of encryption algorithms, and this stands for Advanced Encryption System. I believe that's what the S stands for. It's just a encryption algorithm, one of many. All right, well, let's talk about PKI. So I want to come back to my agenda. So we talked about symmetric. And symmetric is fairly easy to explain, and it works really, really well. The problem with symmetric is if you're at home and you want to go to Amazon to buy something, you know, how do you exchange the symmetric key? So we want to use symmetric because it's a relatively short key and it's a relatively efficient key. But the problem is, how are you going to exchange the secure key between your home computer and the Amazon computer? And this is why we invented asymmetric, or PKI, public key infrastructure. And asymmetric requires a digital certificate. And when somebody, a computer creates a digital certificate, they always create two keys. And this is really important. They create a private key, and just like it says, it's private. This is for you to keep, for the enterprise to keep and not share with anybody. And the other one is a public key. And the public key is public. You know, go ahead and put it in your website and share it with the universe. And when the private and the public keys are generated, they're generated in such a way that whatever you encrypt with one key, you can only decrypt with the other. So if you encrypt with private, you can only decrypt with public. If you encrypt with public, you can only decrypt with private. And because of this complex relationship between private and public keys, those keys tend to be really long. So 512-bit is the shortest. Remember, we said for symmetric, 256 is a very, very secure symmetric key. For digital certificate, 512 is just way too short. And even 1024 is insecure. So those keys have to be really long. And 2048 is considered to be safe. And longer is, of course, better. And the problem with long keys is they are taxing. It takes longer to do what you need to do with a long key than it is to use a short key. And this is why we want to use a strong key, but not super long. You know, we could use 1024 symmetric key, but what for? 256 is very, very secure. So let's just use 256. It does the job and it does it effectively. And we want the same thing for those private and public key. We need a key that is long enough and secure. And like I said, 1024 is very long, but in private public, it's considered to be weak. Nobody uses 1024. You will see 2048 and up. So whatever you encrypt with one, you decrypt with the other. And I want to come back here for a second. And we have these encryption protocols. So we have SSL and the newer protocol TLS. And these run at the application layer, and the application has to call them, and I want to talk about. And then we have IPsec, and IPsec is also an encryption protocol, and it's very different. It's fundamentally similar to SSL TLS, but it's very different because it runs at layer 3, which means the application doesn't really need to call it, and the application doesn't have to encrypt because IPsec will encrypt down here at layer 3. The other difference about IPsec is SSL is a protocol and TLS is a protocol, and IPsec is a buffet of protocols. That's what I like to call it. It's a buffet. They have a buffet of hashing algorithms. They have a buffet of encryption algorithms. They have a buffet of authentication algorithms. And this is what makes IPsec wonderful, is if there's a brand new encryption, brand new hashing, well, all they have to do is just add it to that buffet table. And it still is IPsec. So IPsec isn't really a single protocol. It is a buffet of protocols, but all of them are focused on encryption, hashing, authentication, and we'll cover IPsec in a lot more detail later on. But let's talk about how Ssl Tls work. So you log on to Amazon.com using HTTPS. And if you remember last week, we talked about Telnet and SSH. And I said, please don't use Telnet. Nothing is encrypted, including the account name and the password. Please use SSH. And if you remember, when we configured the router for SSH, we had to create a digital certificate, because SSH, which sits in the top of SSL or TLS, requires a digital certificate. And usually you would go to a certificate authority like VeriSign, Symantec, etc., to get a digital certificate. But for our own purposes, we can generate our own. We don't really need to pay for that service. And almost all operating systems are capable of generating a digital certificate for you that isn't honored by anybody else, but you can use it for your own private purposes. And if you remember, when we tried to generate the key, it defaulted to 512, and I said, no, I want to use 2048, because 512 is very short asymmetric key, and it's fairly easy to crack. So let's come back here. So you logged on to Amazon.com using HTTPS, which is HTTP over SSL, or TLS, which is just a newer flavor of SSL. So what happens? So let's take a minute or so and talk about this. And please, let's make sure this makes sense. It needs to make sense in order for the rest of the class to make sense. And then we can go back to chapter 2 after that. So you log on, here, I'm going to do it. So I'm going to go to Amazon.com. And you can see the log. So this is HTTPS, not HTTP. And HTTP and HTTPS are TCP, use TCP, not UDP. And TCP does a handshake. I'm sure you remember all of that. So we go ahead and do a handshake. My computer and the Amazon computers do a handshake. And I don't have a digital certificate, nor do I really need one unless I want to use secure email. And we'll talk about secure email later on. But the vast majority of us don't really have a digital certificate, nor do we want to pay. We can, but we'll have to pay for that, and we don't want to do that. But the Amazon web server, all these computers you connect to on a daily basis, Gmail, Google, etc., they all have a digital certificate. So we do the handshake, and then at 1,000-foot level, the server, the Amazon.com server, is going to say, okay, this is my public key. And remember, whatever you encrypt with the public key, you can only decrypt with the private key. And then my computer is going to generate a symmetric key back to a shorter, much more efficient key. It's going to generate a session key, and that session key is a symmetric key. And then it's going to encrypt it with the Amazon.com public key, and then we're going to send it back to Amazon. And Amazon is going to decrypt it with their private key, extract the session key, the symmetric key, and now I have the symmetric key, they have the symmetric key, and everything we do from this point on, we're using that session/symmetric key to encrypt back and forth. So we're only using this private public key to securely exchange a session symmetric key. We're not really using it to encrypt everything, because that will be very taxing, because those keys are very long. And I don't have one. If I did have a digital certificate, then we could use my digital certificate and their digital certificate to encrypt everything back and forth. But I don't have one, nor do I need one. But we need to exchange a session key securely, and we use this private public key to do that. So this is at 1,000-foot level. There's a lot of nuances, details, agreeing on which algorithms to use, agreeing on the length of the symmetric key. And of course, they're going to agree on the strongest algorithms the two computers support. So whatever my computer supports, whatever the server supports, hopefully they will agree on the strongest algorithms, and then they will go from there. Does that make sense?
Yep.
Do you think you can explain it to your roommate, your significant other, your dog, your cat? Because this is really the acid test. I don't want you to say, yep, makes sense. Okay, if it makes sense now and you can't explain it to someone else, you're gonna forget. And you don't want to forget that. So I'm here. Let's go and take a look at the Amazon digital certificate. So I'm gonna come down to more tools. Let me move this. And let me move it here. And then I'm gonna, and you can tell it was given issue to www.amazon.com. And the issuer, the certificate authority is DigiCert. And it's good until the end of this year. And if I was to go to details, and I'm not gonna go over this, but you may wanna do that. There's lots of web pages that will explain each of these fields, you know, in a paragraph or so. So this is SSL version 3. We're using this algorithm for signature. We're using this algorithm for hashing. We saw SHA 256 before last week. And this is the public key. And you can see it's 2048. And RSA are the initials of the 3 people that came up with these set of algorithms. And it is a encryption. It's a PKI algorithm. And it's 2048-bit. And it's 2048 not because they want it to be super secure, because this is the bare minimum you would need for a PKI key to be considered secure in 2020. 1024 is just not secure. And that's because of that unique relationship between private and public. And this is the public key in hex. And like I said, it's public. What you're not gonna find here is the private key, because that they need to keep to themselves. So to go back to a signed file, let's take a look. So if I was to go to my C drive, Google, here was, okay, let's see if they, is there an exe? Properties, here we go. Okay, so now we know what that is, right, everybody? This is a hashing algorithm. So this is the algorithm that they used to produce the hash key for that file. And now if we are to go and look at the details, and this is their certificate, and of course, no, they're not showing us their private key, but that's what they signed that hashed key with. They encrypted it with their, sorry, no, that's true. They did encrypt it with their private key. So it's a two-step process: generate a hash key and then secure the hash key by encrypting it with their private key. And now at my end, I can decrypt using their public key. I can generate a hash, and then I can compare those 2 hash keys to each other. And if they're the same, then no one has altered that file. Intentionally or unintentionally, that file hasn't been altered. And this is a step further than the frame CRC, because we don't really digitally sign that, nor do we need to, because we're just checking the integrity of the frame. And we have gazillions of frames going back and forth. But this is a file, and Google wanted to make sure that no one is going to alter that file. And you and I want to make sure that this file hasn't been altered. This is the file that Google sent, or Microsoft, or whoever sent. And signing those files are a common practice these days. So the last thing I want to talk about before we go back to chapter 2 is Mime, which is secure email. And secure email is quite popular. If you work for a financial institution anywhere in planet Earth, you know, you're using secure mail. And to use secure mail at both ends, the two parties have to have a digital certificate. So let's say Paul and I, Paul Skarka from the class, and I, you know, want to exchange email securely with one another. So he needs to go and secure or obtain a digital certificate, a private and a public key. I need to do the same thing. He will keep his private key to himself. I'll do the same, and I will give him a copy of my public key, and he will give me a copy of his public key and import it into my system. And if we are using an Mime capable email system, next time I want to send him an email that is encrypted, I will encrypt it with his public key. I don't really need to do anything other than just say I'm sending an email to Paul and I want to encrypt it. And the email handler will do the same thing. And he is the only guy with the private key. He's the only guy that can decrypt. And then when he receives the email, he can decrypt it with his private key. And then if he wants to send a reply that is encrypted, then he will encrypt it with my public key. Okay. And then there's this other thing called non-repudiation, which basically says this really did come from Zico. It didn't come from someone else. And if I want to do that, if Paul and I want to do that, then we have to do a second step. So encrypting the payload with the other party public key, we already covered. And if you want to say, yep, this really did come from me, it didn't come from anyone else, then I'm going to have to digitally sign that email message. And what I do is I take the payload, I produce a hash key, we already covered that, and then I will sign it with my private key, not public key, private key. And then anyone with my public key can see this did come from me. And then I will send it to Paul, and Paul will decrypt the content of the email using his private key. And then he wants to make sure it did come from Zico. And then he will decrypt the hashed key with my public key. And then he will compare the two hash keys and say, yep, this really did come from Zico and nobody else. And by the way, this is something that can stand in US court. So if I was to send you something that is digitally signed, I can't say, nope, this didn't come from me. It did come from me. So this is this. Any questions? Again, the acid test, the real test is, can you explain it to someone else? I'm confident, you know, you're nodding along and you're saying, yep, it makes sense. But the true test is, can you explain it to someone else? So I challenge you, everybody, you know, research it, study it, read about it, and then see if you can explain it to somebody else. And please master this stuff, hashing and encryption. This is a security class. Even if this wasn't a security class, we all need that knowledge in the IT field these days for all kind of different purposes, all of which fall under either integrity or, integrity or confidentiality. All right, let's go back to chapter 2. I'm done with this. So very, very quickly, just want to show you something. When we were doing SSH, here we are. Do you guys remember crypto key generate RSA back to RSA? Okay. And then it said, do you want a 512 between parentheses, meaning if I hit enter, it would accept 512. And I said, no, thanks. I want you to use 2048 because this is the bare minimum that is acceptable in 2020. And what we did here is we used the iOS operating system to generate a private public key using a 2048 key. All right, let's move down. Don't worry, I'm not going to go over all of this, but I do want to talk about this. Okay. So physical security, by now you all know there is no security without physical security. The next lab we're going to do is to secure the operating system and the configuration file. And router hardening, server hardening basically means make them more secure and improve the uptime. This is what hardening means. You know, do whatever you need to do to ensure that that service is up and secure. And we talked about strong passwords and how easy it is to crack an easy password or a password that uses a short key, like 16 bits. And we said to protect against brute force, we want to disable the login process for so many minutes or seconds. We talked about SSH. And then we talked about limiting availability. We talked about the, what did we talk about? We talked about the privilege levels. And we said you can create a privilege level between 2 and 14, assign some commands to it, and then attach it to a user if you want to limit what the users can do. And we said we can also do role-based to accomplish the same thing. And we said role-based is a hierarchical model, so it's a little bit more flexible than the previous model, a newer model. And that's where we stopped. Okay. And this is talking about the resilient configuration features to protect the iOS, because if you are a black hat hacker, what you really want to do is you want to take control of the operating system. Or in the case of a switch or a router, you want to take control of the configuration files. Make sense, everybody? So we want to protect those two files because the iOS operating system is a file. So we want to protect that file, and we want to securely back up the configuration file. So if someone was to change them for whatever reason, again, accidentally or intentionally, we want to be able to restore the proper configuration for that device. So this is what this lab is, and I'm just going to dive into the lab. And this is lab number 4. And we're using iOS, which is capable but doesn't support everything. So we're using the same physical topology we have been using for chapter 2. So I'm going to log on. Console 123, I'm sure you remember this. And triv mode 123. And it tells me to go into global configuration, conf t, and do show flash. And flash is the persistent permanent storage. And you can see the iOS operating system file. I just highlighted it, C1900, etc. And if you're curious, signature definition, these are malware, specifically intrusion prevention, intrusion detection, which we'll cover later on in this course. But we won't be talking about them today. And then if I was to do dir nvram, and I'm sure you remember nvram is non-volatile RAM, which in my opinion is an oxymoron because RAM is volatile. But when you leave things to, with all the respect to engineers, they come up with weird names like nvram. And you can see the startup configuration file. So these are two super important files, the iOS operating system file and the startup configuration files. And we want to protect them just in case the system gets hacked. And we want to be able to restore the original operating system, and we want to be able to restore the original configuration. So this is what we do. So there's a command called secure question mark, and it says, what do you want to secure? You want to secure the iOS, or do you want to secure the configuration? So those are the two options. So we're going to start with boot config, which is the boot file. which is the iOS operating system, and that's it. And now I've hidden, and I'm going to show you this. And now if I was to do show flash, and I want to do image. Sorry, everybody. How about we do image? Okay, very good. And now do show flash. And you can see the iOS operating system is no longer visible. It didn't go away, we just hid it. Okay. And now if I was to do secure boot set, you're going to see both of those files because I already did the secure boot config for the configuration file and boot image for the iOS operating system file. And I will show you where they are. Do show secure boot. How about if I spell secure correctly? And here they are. Here are the two files. This is the iOS file. Okay. And this is the configuration file. Everybody? So let's say, something awful happened to this router, someone hacked into it, someone did something weird, and we want to restore it to its original configuration, original operating system, original configuration, because according to Cisco, those files are secure now. Remember the command secure. So we've secured those files. So people can access the device, they can make changes to the device, but they're not going to be able to access those two files. They can see them, but they can't access them. You can only access them from ROM-mon, that tiny operating system that is in the ROM chip. And we're going to be logging into it pretty soon. And to do this, you have to reboot the router, and everybody's going to know that something awful happened to the router. So let's go ahead and restore the original operating system and configuration. And to do this, we need to reload, restart, and then interrupt. How about if and interrupt the boot up process. And when you interrupt the boot process, you go into ROM-mon. Does everyone remember ROM-mon? So if you're unable to load the full-blown iOS operating system, or if you were to interrupt the boot process, this is where it will put you into. And I want to show you a slide you've seen before. You guys remember this slide we've covered before? It talks about memory, storage. So we have RAM, we have ROM, we have NVRAM, we have flash. We all know what RAM is. This is where the running configuration is running. This is where the iOS operating system is currently loaded into. This is where all of your dynamic tables are loaded into, your routing table, your MAC address table. And this is ROM, read only. And what we have here is this limited iOS. And this is this ROM-mon operating system. It's a limited iOS. And it's basically for troubleshooting, which is what we're doing right now. Or if you want to download a newer version of the operating system, you can do it from here. And we have NVRAM, which is non-volatile RAM. And this is where the startup configuration files are. And then we have flash, which is persistent permanent storage. And this is where the iOS operating system is. And this is where all of your permanent files are. So this is a slide we've seen before, but it's good to review. So let's go back to our lab. Okay. And here we are. And if I was to do a question mark, you can see, we don't really have access to very many commands in here. This is just a limited operating system that was designed specifically. So if you can't go into iOS, you can go into ROM-mon for troubleshooting purposes, downloading a new copy of the iOS operating system purposes. So we did this, okay, and now let's do dir flash, how about dir? Okay, and now you can see the iOS operating system file. Cool, everybody? So this is where the operating system is, and we want to boot from here. Okay, and now we can type. First, we have to copy it because I don't want to have to type it, and then you type boot, and you boot from this operating system, which is the proper operating system. And then we're going to fast forward. Okay. And now I've booted into the proper operating systems. It's prompting me for passwords, console 123, priv mode 123. And now I can do write, and I'm good, and I continue from here. The other thing we need to do is we need to restore the configuration file, right, everybody? So we restored the iOS. This is what we did. We hit it, and we booted from it, and we restored it, which is very good. And now if I was to do show run, okay, so these are the configurations, and if someone had changed those configurations, we want to restore the original configurations, not the ones that have been hacked. And then these are the commands that you do, and unfortunately Packet Tracer doesn't support it. So I'm showing you the commands, but I can type them, but I will get error messages. For example, if I was to use, let me see over here. Okay, good. Yep. So if I was to go to conft, I can do secure ? And I can do secure boot config . And that's all I can do. So this is basically telling me you've ran out of choices. You don't have any more choices, and Packet Tracer doesn't support those options. But we can certainly restore the iOS, the proper iOS in Packet Tracer. Any questions about what we just did or why we did it? Okay, let's move on. And I don't believe we've done this in a previous class, because some of the other Lab 2 activities, Chapter 2 activities, we've done in previous classes, but not, I don't believe we've done this in a previous class. Okay. So we've covered this. And recovering a router password. And this happens in the classroom all the time. A student is using a router, they type their favorite password in, they finish the lab, they go home, and then the next day another student wants to use the router or the switch and they can't log on because they don't know what the password is. And Cisco gave us a mean of being able to change those passwords. And this is what we're going to be doing next. And I'm just going to go ahead and do the lab. And this is something we've done before. I know we did this in 152. So not too long ago, in the winter quarter, in one of the chapters, we did this. So we're going to redo it today. And this is recover password. And this is something we can do fully in Packet Tracer. Same lab. So let me log on. Same passwords or passwords. Console 123. Priv mode 123. Okay. And I have to do a show run. Okay, show version, sorry. Show version, and show version is showing you a lot of information, and we'll come back to this later on so you can see the version of the operating system you're using. You can see the version of the ROM-MON mini operating system you're using, and the two can be different, and they usually are. You can see the licensing down here, and in later exercises, we have to enable the security features on the router so we can use these features, which is an add-on and you pay for. And then at the very, very end, it's showing you configuration register is, okay? And we wanna change this to a different value that isn't gonna prompt us for passwords. And then we will log on and change the passwords, and then we'll change this registry value back to 0x, and by now you all know 0x is hex 2102. And it's going to be different for different routers, different kind of routers, and then you just have to Google that to find out what is the value. But I know for C1900, these are the proper values. So let's go down the lab. So we have to go back into ROM-MON, and we want to change the register value to 2142. 2142 means, you know, don't prompt for password. And then we'll change the password and change it back to 2102. Does that make sense, everybody? So it should always be 2102, unless you've forgotten the password and you need to reset the password, and then you change it to a different value. And then after you change the password, you change the register back to the original value, and you go from there. So the process is fairly easy. We did cover this in 152. So let's go ahead and power cycle, Control C, and here we are back on ROM-MON. And now I want to change the register to this value right here. In fact, I can copy and paste. Okay, I changed it, and now I can boot into the iOS operating system, fast forward, and you will see now here we are. And you've noticed no passwords. It's not asking me for passwords, which is what I want. And now I can change the passwords to whatever I want and change the value back to the original value and reboot and go from there. Okay. So enable and copy startup. Yep, I want you to do that. And show run. So these are my original values. However, I don't know what the passwords are because the passwords are encrypted, but I can change them. Okay. And now I can change the register back to its original value. Restore the register to the original value. So let me copy and paste. Yep, I took care of this, and now I can change the passwords. So enable secret, which is for the privileged mode, priv mode 321 instead of 123. So this is the new password. And I want to change the console password. That's another password I want to change. And line on 0 and password console 321. And I want to save and reload. Right, reload, fast forward, And I needed to enable the interface, but that's okay. I can do it now. And the new password is console321. And the new password is privmode321. And I needed to enable. And now we're in business. So this is really important because these scenarios do happen and has happened many times in my classroom where somebody will change the password and they'll go home. And then the next day I would have to do exactly this to remove the passwords. So the next student can use a switch or a router. And it happens in real life because people quit, people leave, people go on vacation, and you need to access a switch or a router and you don't know what the password is. And this is the process to do it. Questions? Do you remember this from 152?
I did 152 with Parker, and I don't think this is something that we covered. So this is kind of new to me.
Okay.
I mean, he talked about doing it, but he never showed us or had us do it.
Okay. Do you see the value of it, Frank?
Oh, definitely. Yeah. Because there's been plenty of times that we've gone in there and we couldn't get it to it. And then Parker did whatever he did, which was obviously this. So
this, that's exactly what he did. He did this. Yep. Very good. Very good.
Would it be possible to get this packet tracer so we can practice as well?
Yeah, everything I'm showing you, you have access to, and I'm going to show you one more time. And thank you for asking, Joey. So I'm going to go to Google Drive, and I've sent you the URL, and I'll be happy to send it again. I'll show you where to find it. 285. Okay. This is the network table. These are the slides, Packet Tracer Labs. This is what we did last week, week 1. And these are the chapter 2 labs that we're doing right now, Joey. And then to find the URL for this, just go to Net Academy and look at the emails I've sent you. So this is 285. Inbox. For me, it would be sent email. And then look at the welcome messages. And you will see the URL.
I also dropped the copy of the URL in the Zoom chat.
Okay, very good. Thank you. Excellent. Yep. And I want you to copy these, and I want you to do them on your own. Please, everybody, you know, do it on your own at your own time. You may have to do it twice, 3 times until it makes sense to you, and then move on. And I do know I go a little fast, and one of the reasons why I go a little fast is because you have access to those files, and you can do it on your own. I just want to make sure you understand what it is we're doing. And I tried to put some explanations in the Microsoft Word file to help you along. Okay, I'm going to move on. So we did this. Okay. So we talked about in-band and out-band, but I want to show you this, everybody. Okay. So IPsec. So what's the magic word with IPsec? 2 magic words. Magic word number 1, it runs at layer 3, not at the application layer. What else do you remember about IPsec?
The buffet of protocols.
It's a buffet. Thank you very much. It's not a single protocol. We refer to it as a single protocol. It really isn't a single protocol. It's a buffet of protocols. And this is why IPsec will be around for a very long time. They'll just keep adding new protocols to it. So it's scalable, it will grow over time. Like, you know, we started with SSL and then it's like, okay, we'd like to make some significant changes. Let's develop TLS. And in 2 years, we may have some other acronyms in here. And fundamentally, they do the same thing, but they do it differently. Well, IPsec isn't a single protocol. It's a buffet of protocols, but it deals with security. Clearly, IP security. This is what the SEC stands for. And we're talking hashing, and we're talking confidentiality, and we're talking authentication too. And we know what SSH is, and we've been talking about SSL, which requires a digital certificate, at least on one end, for things like SSH and HTTPS. If you want to do secure email, then you would need a digital certificate at both ends for confidentiality and for non-repudiation. Okay. Here we go. syslog. Okay. So logging is important, right, everybody? We've already covered this. Logging is super important. You want to log not everything, because you don't want your log file to be massive, and it will be just a waste of disk space, and it will take you longer to mine as the log file gets bigger and bigger. But you want to log the important stuff. Okay. And if you remember when we covered CS240A and we talked about logging, maybe we're covering it in B, I don't remember. You know, you have to decide what kind of logging you want to do. Do you only want to log when they modify the file? Do you want to log when they read the file? Do you want to log when they create the file? So you have to make those determinations. And which files? Because clearly, you know, if it's a public folder with just public information files in there, you don't really want to log at all. What's the point in logging? It's a public folder, and it doesn't really have any sensitive private information. But then if it's the payroll file where payroll department keeps track of who's getting paid what at the end of each month, well, clearly you want to log that. You may not want to log the read, but you may want to log every time someone writes. And if it's an engineering department and they're working on some really hot new product, well, you want to log everything. You want to log anytime anyone touches these files, because these are highly sensitive files, and you want to know if someone is reading it, you want to know if someone is changing it, you want to know who read it, when, and who changed it, and when, and so on. So logging is very, very important. And we talked about cyber attacks last Tuesday, and I did say, you know, sometimes it takes a company 6 months or longer to find out that they've been hacked. Well, what do they have 6 months later? All they have are the log files. And if your log files are empty, then you don't have very much to go on. So hopefully you've been logging all that information, and you can log it for monitoring purposes, you can log it for management purposes, and you can you can mine it for management purposes, for monitoring purposes, and of course for cybersecurity purposes. So this is my spiel about the importance of the super high importance of logging. You have to log. And this is what the next few slides are about. So unfortunately, Packet Tracer is not very capable when it comes to logging. We will do something with it, but we're not going to be able to do very much. But what's really important that you take away is, we must log. That's what I want you to take away. Logging into a file, not logging into the console, on a monitor. That's fine for your own purposes, but no one's going to go and look at what showed up on your monitor 6 months later, or even an hour later. So you want to log into a file, and you want to keep those files for a very, very long time, because it may be 6 months before you realize something fishy is going on, and I need to go back from a year ago and see what's been going on. Okay. So this is so you have a syslog server, and then, you log events to that server. And then you have to determine which events you want to log. So here we are. So remember the events. So according to syslog, These are the different security levels. Highest level is 0, emergency, red flags, sirens going on. And then 1 is alert, 2 is critical, errors, all the way down to informational and debugging. So lowest priority is debugging, informational, highest priority is emergency, and you have to decide where is that line. Okay, and I can't tell you what the answer is, but I can tell you log. I just don't know where to draw the line. Should I draw the line at 3? So 3, 2, 1, and 0 you must. 4, 5, 6, and 7 optional. The answer is almost always it depends. Are we good, everybody? And when you log, you most certainly want to log date time. So you always want a date time stamp. You want to know when. Okay. And you want to know who, if you can. And you want to know what, right? Just, the things you would expect in a log file. So when did it happen? Who did it? And what did they do? They modified this file. They read this file. They created a file. And of course, that doesn't apply to a router. But for a router, it could be they changed a configuration file, or they enabled an interface that we usually don't use, or they disabled an interface that we use. And you want to log all that information. So we have a sequence number, we have a timestamp, we have the severity, we have a description and a short description. And the reason for this mnemonic is mostly for searching purposes. So when you are searching, when you are mining that massive log file, and these log files get really massive, you can mine it using the severity level, you can mine it using the mnemonic. So let's do a lab. So this is the next one, 6. And this is the same lab. I just added a syslog server to it. And you can see how short it is. And it's pretty short because Packet Tracer is not very capable. And what's really important for me is that you get it. Like, logging is important. We have different severity levels. I have to draw where that line should be. And then the detail is detail. It's important, but you can always Google it. You can always look it up in a manual. You can always look it up in a file, as long as you know this is something I must do. All right. So let's log on to routers. Sorry, let's start with the server. Let's follow directions. Okay. So I'm going to start with the server, services, syslog, and it's enabled. Okay. So this is my syslog server. And you don't really want to have a separate file for every router and a separate file for every switch. Think about it. What if you have 20 routers? Do you really want 20 log files? Wouldn't it be better to put all of them in a single file? So when you talk about logging files, it would be excellent if you can identify a log server and consolidate so you wouldn't have to mine so many different files for the same kind of data. And this is what we're doing here. So let's log on to the router. Console 123, priv mode 123, and then logging host, everybody. So I have to say, okay, where is my log server? Let me copy and paste. Okay, how about if I'm in global config? Okay, very good. And trap, so let's see what it's telling me for trap. logging, and these are basically the severity levels, everybody. And you see, the only thing we can do in Packet Tracer is debugging, and just to put it, okay, and it's the lowest level. So we can do 0 through 6. All we can do is just 7. But this is what they gave us in Packet Tracer, and that's the only thing we can demo, and you can do in Packet Tracer. But if we could do, 6, 5, 4, 3, then we will enable them, and then we can do events that would correspond to, 4, 5, 6, and then they're gonna get logged. Okay, debug is all we can do, and logging on, turn it on. And now I need to do something that generates a trap, and I know if I was to shut an interface and restart it, that is a debugging trap. So I'm going to do that interface gig 01 and no shut. And let me see if I do. So it's giving me some information here, but more important, let me go over here and syslog, and here we are. Okay. Can I make it bigger? Voila. Okay. The one thing I didn't do is capture a date timestamp, which is super important. But again, we're running into the Packet Tracer constraints, limitations. So logging isn't a difficult thing to explain, nor is it a difficult thing to enable. And it's a must. In my IT experience, logging is a must. And if someone suspects you're being hacked, and then they say, do something about it. Well, what does do something about it mean? It means go and mine your logging files, unless you catch someone in the act, right? Everybody, if you catch somebody in the act, you catch somebody in the act, but the odds are small you're gonna catch somebody in the act. The odds are much, much higher that you're gonna find out later on that something bad did happen a week, 2 weeks, 3 weeks ago. And 2, 3, 4 weeks ago, all you have left is your logging files. And that's what everybody relies on to figure out what happened. Questions on syslogging?
I was just looking at it. If somebody were to have access to the switch, is syslogging available on there in case like they shut down the port that the syslog is on?
Yes, it's an iOS function, so it's available for switches and routers and multi-layer switches and so on.
Okay.
And ASA devices and you name it. And the same thing is true for servers, for computers. I mean, you can enable logging on your PC. And we will definitely enable logging on the servers. I don't know if we've done this in CS248. Did we do this in A? Did we do logging?
I don't specifically remember us doing it.
Then we'll definitely do it in B. We will definitely do it in B. And remember, when it comes to file servers, you have more granularity. It's like, which do you want to log everything that happens inside a folder, inside a tree? Is it just this one file? And then, what kind of logging are you interested in? Is it when they create, when they delete, when they read, when they write? Or is it everything? Because you could say, if it's, let's say it's a super sensitive folder with super sensitive set of files, let's say some bleeding edge R&D project, then you can say log everything. I don't care, what they did. I want to know. I want to know who went in there. I want to know who created, who deleted, who modified, who read. And then you can log everything. And it may be appropriate for that kind of a folder. But you certainly don't want to do it on every folder, because it will not be very long before you have terabytes worth of logging information. Move on.
I think so, yeah.
Okay, so this is this. So the next item is Snmp. And I know we've talked about Snmp, and it's not terribly popular. It's a management tool. Let me see. Here we are. So Snmp. Okay. Simple Network Management Protocol. I believe this is what it stands for. Snmp, Simple Network Management Protocol. That's what it is. It's an internet standard. Very good, everybody. So this is not a Cisco thing. This is not a Microsoft thing. This is not a Google thing. It's a standard. It's not a terribly popular standard, and you will see why fairly. And it's been around for a very, very long time. And like all protocols, it has evolved over time. There's version 1, version 2, version 3. And this is true for any protocol. You pick whichever protocol you want, and you will see version 1, version 2, version 3, version 4, and so on. So it's been around for a very long time. And some people do use it. And it's available in all platforms. Your PC supports Snmp, your server supports Snmp. You know, pretty much every device supports Snmp. And you can use it to see what is going on in that computer, you know, how much RAM do they have, what kind of an operating system they're running, which version, how much disk space they have, how much of it is still available, what's their IP address, blah, blah, blah. And you can also use it for management, just like the M says in here, where you can change somebody's IP, you can change someone's DNS, you can change values on these remote computers. So we have get and put, and get is to find, you know, what is available on that platform, and put is to change the configuration. So these are the two basic commands for Snmp. And I will show you why so many people aren't crazy about it, and you will see that. It's useful, it's capable, but we have much, much better management tools these days. In 2020, not very many enterprises are dependent on Snmp to do any of the stuff I just finished describing. But it's been around for a while, it's been evolving. And let's just dive into it. So let's do the lab. Is this working for you? Just talk about something for a minute or two and then do the lab?
Yeah.
Okay, you can do the slides, and I want you to do the slides, not really the slides, I want you to do the Net Academy materials. Please don't do the slides, because it's a subset of what's available on Net Academy. So for each chapter we cover, go and, you know, over the Net Academy material. So let's do Snmp. Yep. And we have, I already said this, I'll say it again, you know, it has been evolving. There's Snmp version 1, version 2, version 3. And this is universally true. If it's a piece of software, right, everybody, and it's still being used, it's evolving. It's not the same piece of software anybody was using 10, 15 years ago. So SSL, you bet, you know, and in fact, when we were looking at the digital certificate, it said version 3. Which means, you know, we had version 1, version 2, maybe version 2.1, 2.2. And the same is true for every protocol. And then when we looked at the Microsoft Office encryption, okay, I don't think, you know, they have versioning for it, but it evolved over the years from 16-bit to 256-bit encryption key. So I'm going to log on to the router. Conf T, Snmp server, Okay. And I have to specify a community. And this is basically the community of devices you want to manage, because you may have multiple communities. You may have a PC community, a server community, a router community, a switch community. So just to keep it simple, I'm going to say LBCC, read only, read only, and read write. Okay. So let's talk about traps, everybody. This is another feature. So we talked about get, which is informational. Let me find out what is this platform and what's running on this platform. There is put, everybody. Let me go ahead and put something or change a variable. And then there is a trap. And traps are wonderful. Traps are great. Traps basically is saying that if I cross this threshold, please notify me. If my disk space utilization exceeds 90%, let me know. If this interface utilization exceeds this percentage, let me know. If my RAM utilization exceeds this percentage for this length of time, cool, everybody, let me know. And as an IT guy, you have to appreciate traps, because you don't want to wait for the users to call you and tell you something isn't working. You want to be notified. And this is what the traps do. They notify you. They let you know, hey, something is happening on this system. Go and take a look. And I don't think traps are enabled on Packet Tracer, but it's easy to see the value of traps over and above get and put. Okay. So let me go ahead and specify the server, which is the PC, which is this laptop. So let me go to desktop, and there must be Snmp. Oh, it's MIB right here. Here you go. So this is what we're going to be writing to. So MIB is the database that Snmp communicates with. And what does MIB stand for? Does anyone know MIB? We also see it in other places. Management information base. Cool. It's a database. Okay, that's what it is. So we have a MIB database on these laptops, and we're going to be writing stuff to writing and querying. So we get is query and put is write. Okay, so we did we do that? Let me copy. Oh, okay. I didn't read the note very carefully. We can do that, but if you wanted to do traps, this is what you would have to do. Let me move this over a little bit. Okay. Now Snmp host server. Okay, so this is the feature that isn't supported in Packet Tracer. This is the trap feature that is not supported in Packet Tracer, and clearly we can see it from here. It's not supported. So let's do the get, everybody, and you will see why this is not so very popular. Okay, so I'm going to go to the MIB database. Okay, and then in the address field, I'm going to specify the router 192.168. So this is the router. Okay. And I'm going to click on advanced, and it uses port 161. We all know about ports. And community is LBCC. LBCC. And I want to leave it at version 1 because it supports multiple versions. Okay, select version 3. What did I select? Version 3. Cool, everybody. So this is the device I want to query, I want to put something into, and I specified the communities and the Snmp version. Okay, very good. Now I will show you why Snmp is not very popular. So the table structure is really complicated. So if I want to get to an IP information, this is what I would have to go through. I will have to open this up. I will have to go to standard MIPS. I'll have to open ISO. I will have to open org. I will have to open DoD, Department of Defense. I will have to open internet. I will have to open management. I will have to open MIB2. I will have to open the IP to get to the IP. So this is the problem with Snmp, is the file structure, the database structure is really messy. And people don't want to have to go through all this stuff just to find out what the IP is. There are much better and easier ways to find out the IP than having to go through this messy process. Okay, and then I'm going to select the IP. And from here, I'm going to do, let's see if bulk works. Here we go. And this is the query. This is an Snmp query. But this is the process I have to go through to query the IP information for this router. And if I wanted to modify, then I would change the value and I would do a set. So a get is to query and a set is to modify. And as long as Snmp is enabled on that device, a PC, a server, a switch, a router, and as long as I have permission, I can make those changes. So this is what I don't like about Snmp. It's just a messy. I mean, you really have to write this down to remember how to get from here down to an IP. Do you guys agree?
Yeah.
Okay. And they are much better tools. So it's been around for a while. It's a standard. It's a freebie. It's supported on every platform on planet Earth. I just don't think it's very popular. But I don't know where you're going to end up. And who knows, you may end up working for an organization that does use Snmp for a purpose. Maybe trapping. Maybe they use it just to trap. So whenever a threshold is crossed, you get notified as an IT professional, and that you want, that you definitely want, not necessarily an Snmp trap, but a trap of some kind, because as an IT professional, you don't want to wait for the users to tell you something is broke. You want to know ASAP, so you can address it and deal with it ASAP instead of waiting for the user community to let you know. And Snmp trap can do that. It's just a little messy to use. Are we good?
I believe so, yes.
Okay, move on. Move on.
Yep.
Okay. We did NTP in 152. Do you guys remember NTP, Network Time Protocol? So this is to synchronize the clocks because every device has a clock. And synchronizing the clocks is super important because you have a lot of activities that happen on a clock, and you don't want it to happen 5 minutes early or 5 minutes late. Make sense, everybody? Imagine you have a scheduled job. You want it to run exactly when you want it to run. You don't want it to run before or after because your computer clock is incorrect. So we want to synchronize our device clocks with a master clock, and that way we're all synchronized. And then there's this thing called an atomic clock, which runs on, it's accessible through the internet, and you can synchronize using that clock. Or you can download to a local server, and then you can synchronize with a local server. So this is what NTP is. Here, this is the mess I was talking about. Okay. So we want to authenticate. Okay. So let's do the lab. And this is the last lab I will do today. And then on Wednesday we'll finish. But I do want to talk about this file down here today. So let's do lab. Let's talk about this. And then we'll save the rest for later on. Anyone remembers what CDP is? We will not do it today. We'll do it on Thursday. Sorry, I said Wednesday. CDP, Cisco Discovery Protocol. So this is basically where a device is going to say hello, and another device can say hello back, and then they can begin to exchange information. So why are we talking about CDP in this class? Anybody wants to tell me? So what's the security implications of enabling CDP?
A rogue switcher device could get onto the network with the CDP.
Yeah, exactly. You know, you can start saying hello, and then routers and switches will say hello back to you, and then you say, can you please share this piece of information with me? And then they'll say, sure, here it is. Well, that has security implications. It has benefits. It's always a mixed bag between benefits and negative consequences, and you want to balance that. And if you don't need it, turn it off. In yesterday's class, my 153 class, and a bunch of you are in that class, I was saying, you know, if you don't need that interface up, shut it down. If you don't need that protocol running, shut it down, because they all have security implications, and better safe than sorry. So you have to always ask yourself, you know, what is the security implication of this, whatever this is? And if you, back to CBA. So clearly there are benefits for it, otherwise they wouldn't have created it. But what are the security implications? And if the security implications are big and you're not getting much benefit, you probably want to turn it off. But we will continue this. So let's do NTP. And this is almost exactly the same exercise I did in one. Actually, it is, because you can see we have a different topology. This is the same exact exercise I did in 152. So we have all these routers, all these devices, and we want to synchronize them. So I'm going to go to R1. And whoever took 151, 152 from me probably remembers this topology. And show clock. And clearly this is the wrong clock, right, everybody? It's no longer 1993. So we want to synchronize it with a master clock. And the master clock can be that atomic clock, or it can be a local server that's synchronized with a higher server. And then we can change it. Okay. Show clock detail. Time source is the hardware calendar. This is telling you I'm not synchronizing with an NTP master. This is just what they typed in. show NTP association. There's none. I'm not synchronizing. And show NTP status. And NTP isn't enabled. And that's what we want to do. We want to enable NTP. So on the NTP server, right here. So this is my master, my local master NTP server, which itself could be synchronizing with a higher server. So I'm going to go to services and you can see NTP. And it's on. Very good. And let me set the right time. So we are in April 14. Holy cow. And it is 11:20, 11:30. 11:30 a.m. Is there a set? Nope, that's it. So let me get out and come back in and make sure it's correct. Yep, everybody. And the clock is ticking. So, and if I wanted to authenticate, then you would enable the authentication and you would type in the password and you would authenticate to verify that you're synchronizing with a proper NTP server, not some bogus NTP server. Okay. So in R1, R2, R3, we're not going to do all of them. Let's just do one. So let me go back to R1. Okay, NTP server. This is really easy in terms of concept and implementation. So NTP server 192.168.1.3. About conft. Hey, you guys are not helping me out. NTP server 192.168.1.3. Okay, and do right. And I'm done. Okay, so now let's fast forward a few times. Come back here, show clock. Everybody? Okay, so I synchronized this router with the NTP server. And now if I was to do those commands again, show NTP association. And you can see I'm synchronizing with 192.168.1.3 and status. And it's a lot of details, but I'm synchronizing with 1.3 and detail. Clock detail. About just show clock detail. Here we go. And this is the time, and time source is NTP. Do you remember when we started, time source was hardware, was local, and now the time source is the NTP. And every so many minutes, it will go back and synchronize one more time. And I can do this on all of those devices, and they will all synchronize with the NTP server. And those devices aren't only routers and switches, everybody. So servers as well. So basically every IT device, whatever IT is managing, you can synchronize all of these devices, Windows, Linux, Unix, etc., with an NTP server. And make sure all of these devices have the same and correct time. Would you agree? Nothing complicated, just straightforward?
Yeah.
Okay. So let me ask you a question. Where did the NTP server get its time from? Or in a production environment, where would it get its time from?
Other than us setting it, wouldn't we have it based on the atomic clock so that it's
Yep, there you
actually
go.
accurate.
Yep. So, and you can find out the IP address for the atomic clock, and then you can configure your master NTP for the atomic clock IP, just like we did for router 1, except you're getting the time from an atomic clock. And that's how you synchronize the master NTP server inside your organization, and then everything syncs with it, because you don't want all these devices going out to the internet. It's better, and it's easy to understand why, just to have a single NTP server inside the enterprise, and then everything synchronizes with that 1 or 2 devices.
Hey, Zico. So with the clock being set forward and reverse for the spring forward and go back to standard time, does the syslog run into problem like an error if you moving back or moving forward? There's a skip in the syslog.
I'm thinking. I don't want to say yes or no. I would say Google it and find out.
Okay.
So I don't know the answer for that. I was hoping you were going to say, does it synchronize? Does it change, from daylight saving to standard daytime? And the answer is clearly yes.
Yeah.
But does it log it? I don't know if it logs it, but it clearly changes the clock automatically for you.
Okay.
Questions? So let me show you what I want to talk to you about, and then this is it for today. But we're not done, because there's one more thing I want to cover. Okay. So let me exit out of here, and we do have a few more labs, and we can do them. And there's nothing really complicated here. CDP is very easy, auto-secure. It's just a self. We will cover it on Thursday. And MD5, do you guys remember MD5? It's a hashing algorithm. And to just show you very quickly. So I go back to the same architecture or a similar architecture, and these routers are configured for dynamic routing protocols. We want to make sure that they can trust the other router they're doing business with. And we're going to be using a password and MD5. And the MD5 is to hash the password and to authenticate the neighboring routers before you exchange information with them. So nothing complex, and things now we fully understand. Hashing and using that hash to authenticate. And that's it for chapter 2. So I want to talk about RSA and ECC, but let me show you. So let me go to Google. First, let me go to Net Academy. And it's secure, right, everybody? And if I was to look at their certificate, and it's valid and trusted. So where did I go to get this piece of information? So I went to the website. I'm using here. I'm using SSL version 3, okay? And they have a digital certificate from DigiCert, and it was given for specifically this device, www.netacademy.com, and this is telling me valid and trusted. So how did we get to valid and trusted? Please speak up. I know you know. Some of you know. So we went to the certificate authority. This is the certificate authority. So we went to the certificate authority and we said, does this digital certificate belong to www.netacademy.com? And the certificate authority said, yep, it does. And this is how we came to valid and trusted, everybody. So let's look at the digital certificate itself. and we're using SSL version 3, and we're using a public key 2048. We talked about that. We said this is the bare minimum that is acceptable these days. Except people are smart. People like you are smart. And they're always saying, is there a way to accomplish what we want to accomplish here using a shorter key? Because a shorter key is more efficient. So we're talking efficiency. And people actually came up with a new algorithm that uses a shorter key and is still just as secure, maybe even more secure than an RSA 2048. And what this buys you and me is efficiency. And imagine, we're using it for SSL, for TLS. Remember, we're only using it to securely exchange a session/symmetric key. So we're not really using that public-private key for very long. And if the key is super long, who cares? It's not going to impact efficiency very much. But imagine you're using it for every transaction. Every time you're sending a piece of data back and forth, you want to use that long key. Well, it becomes inefficient. There's nothing wrong with it, and you want it to be secure, but you're paying a price for it. So let me show you what I'm talking about. So I'm going to go to Google, and I'm going to do the same thing. It's secure. Very good. Same thing. Let's take a look. And they got it from GTS. CA is for Certificate Authority, everybody. And detail, very good. SSL, very good. So far, so good until we get down to here. Did you guys see the difference? How long was the Net Academy key? Does anyone remember?
2,400.
Very good. And this one is 256. 256 is like much shorter than 2048. And I've seen some keys that are 4096. And that's like an incredibly long key, and it's more secure, but it's very long. And it's not as very efficient, especially if you're using it a lot. And somebody came up with a newer algorithm, and it's ECC. And yes, it's 256, but this 256 is more secure than 2048. And I really wanted to bring this to your attention because we're beginning to see more and more of this ECC. Why? Because it's a shorter key that is more secure than a 2048. And then if we stay with Google and come over here and do RSA, that's the algorithm we're using with 2048 versus EEC. And then you can read about it. Okay. And what is ECC? Well, why should we use ECC, everybody? Or was it EEC? What was it? Yep, very good. Okay, very good, very good. So here you go. Everybody, this is what I want to stress. For example, a 256-bit ECC. ECC is the key. Okay. Is the same as 3072-bit RSA. So a 256-bit ECC is more secure than a 2048 RSA. Okay, and they're saying it's about the same as 3072. And that's great. And that is wonderful. And this is important for us to talk about in this course because we rely heavily on these keys to accomplish the security that we want. And yes, we want a secure key, definitely. And if we can get the same level of security with a shorter key, then we certainly want to use the shorter key because it's much more efficient, especially if you're relying on that key for all kind of confidentiality purposes.
When you're talking about efficiency, are you talking about the combination of processing power and transmitting it over the internet? Or are we talking solely on transmitting it over the internet? Because they're both kind of like, internet's getting faster, processing speeds are getting faster.
Yes.
Does a 2048 or a 4096 really incur that much more of a burden?
Very good. It's an excellent question. It's a very good question, Frank. So I'm specifically talking about processing power, because you have to encrypt, right? Using that very long key, and that's going to require local system resources. And then you have to decrypt, and that's going to require local resources. So I'm not talking about transmission efficiency. And we can talk about efficiency locally or over the internet. I'm talking about system resources, using system resources. And if you're using Ssl Tls, then it's not going to make that big of a difference, because I want to stress one more time, we're only using the private and the public keys to securely exchange a session/symmetric key, right, everybody? And once the two computers have that session keys, they're going to use that session key, let's say 256-bit or 128-bit session keys. They're going to use that session key to encrypt and decrypt between you and the server. And we're only using the private public to securely exchange that. But there are cases when we're using that long private public key for many transactions, not just to securely exchange a session key. But let's talk about Mime for just a minute. And you're sending large email messages. Well, now you're encrypting everything with the other party public key, and you're digitally signing with your private key, and they're doing the same. And if you're doing this all day long, it's going to require a lot more local resources to use a longer key versus using a shorter key. And if we can get the same level of security, remember, this 256 ECC is as secure as 3072 RSA. And then the question is, why not use a shorter, more secure key? Especially if you're using it a lot. If you're using it a little bit, it doesn't matter. I agree with you. Who cares? But if you're using it a lot, then it does matter. Did I answer your question, Frank?
Yes, you did. Sorry, I had problems.
It's quite okay. And I really want you to research, everybody. This is a security class. This is a security class. And if you still have any questions about hashing, answer those questions. Do your research. Answer those questions. Understand why integrity is so heavily dependent on hashing.
And I could definitely see this like in a stock market environment where there's hundreds of microtransactions between going on, and you're having to send all that back and forth.
Thank you, Frank. Thank you. I appreciate that. Yep. Or a system that is doing an awful lot of encryption, decryption, it does make a difference. And if you still have any questions about symmetric encryption, remember, your local Microsoft Word, Excel, PowerPoint are capable of using symmetric. So use it, test it, read about it. Always ask yourself, how secure is this? So before you depend on Microsoft Word encryption to protect your sensitive data, ask yourself, how secure is this? And how long will it take someone to break it using brute force? And you can find out. All you have to do is just Google away. And then educate yourself on PKI. Just go to your friend Google and type PKI or PKI tutorial, and then start reading. There's an awful lot of literature out there. And the more you become comfortable with hashing, and the more you become comfortable with PKI, and the more you become comfortable with these confidentiality algorithms, and you get your brain around them, then I think we're going to have an easier time later on when we begin to use them on a much bigger scale. And that's coming later in this course. And you use them every single day. I mean, we use these every single day. It's hidden from you, but it's not very hard to find out what you're using. So that's all I wanted to cover today, but I do want to answer your questions. You do have an assignment that is due tomorrow night. I think almost all of you took the pre-test and the week 1 exam, so thank you for doing that. And there will be a chapter 2 exam this Sunday, but you do have chapter 1 lab due tomorrow. Any question on anything we've covered so far? We're good?
Good.
Yep, good.
Okay. Is this working out for you? Is this online format working out for you?
I believe so, yeah.
Okay. It's not as good, like I always say, it's a mixed bag. I certainly enjoy working out of my own home, but it's not as, to use that efficient term again, it's not as efficient as being in a classroom. What I really miss is seeing you, looking in your eyes. And I can't see your eyes. You can see mine. And what I really missed is just asking you questions along the way. But we're adapting and making the best of it. So stay safe, everybody. Enjoy the nice weather, and we'll see you on Thursday.
All right, sounds good.
Okay.
Enjoy the day. Stay safe.
Thank you. I shall.
As you go.
Bye.